Did James drop the class?
I don't think you can drop this late. All right, so just as a reminder from yesterday, I've still got the 7 steps on the board, okay? So we're going to review that. We're going to do a new example today. Because we did most of the stuff on the board yesterday, I thought maybe today we could do it on the computer so you can get used to that method. Okay? Now, the one thing that I will say, okay? What happened to my screen? I can't see anything. What happened? Something came unplugged. I can't see anything. Well, it looks like I will be calling. I can't see a thing. Do you guys want to just move to the next classroom over?
I don't care.
That'll be faster than getting this. Oh. Yeah, it looks like it's working. All right, so I don't know what happened, or we had a little technical issue there. But hopefully Excel is going to start opening here. Okay, so here's what I would like to do. What I would like to do, you all have the 7 steps memorized, right?
Yep.
So I'd like to do what we did yesterday. We're going to focus mainly, oh my gosh. Why does it make me do this every time? I'm going to have to email the stupid help desk. Oh, that's the wrong one. Oh my gosh, hurry up. All right, so we're going to focus mainly on the test for the one sample mean today, okay?
Okay, so is that categorical or quantitative?
Where the sigma is known.
Okay.
Okay, so if the sigma is known, what would that be?
Should be the sample one, right? The sample would be.
If the sigma is known, is it the sample or is it the population?
Sample proportion.
No. It's not the T1.
Categorical.
No, this is sample.
It's going to be a z-test, right?
Yeah, one sample Z-test.
One sample z-test, so the sigma is known.
So one sample.
Oh my gosh, hurry
And
up.
the T-test are the ones we're talking about.
Wait.
Correct,
Oh.
okay?
Oh, where did?
That's why I was all confused.
Now I don't have
Quantitative.
my correct notes here, let me see. Somewhere I got mixed up. Okay, well, I guess I'll just make up one. I always hate to make up ones because then I usually make up a bad one. And for some reason, I don't have the right notes here.
One
Yeah,
sample.
so if
test
your
is
sigma is known,
estimation.
it's Z. If you don't know, then it's one of the tests.
I swear I did this one before, but I'm going to just do it again. Okay, so here's what we're going to do. You think people are speeding in a school zone. Okay, I'm making up these numbers. This might be an ugly problem. You track 8 cars and find the mean speed is 33 miles per hour in a 25 miles per hour zone. The local police tell you the standard deviation is 5 miles per hour. Now let's make it 8 miles per hour. Is there evidence that people are speeding?
No.
Okay. All right, what is step number 1?
List all your important numbers.
List all important numbers.
Including your alpha, even if it's not given.
Okay. All right, so you think people are speeding in the school zone. You track 8 cars. Oh, there's the number 8, right? 8 is my N. You find the mean speed is 33 miles per hour. What's 33?
Mu or something.
Is it mu?
Yeah.
Yes.
Well, no, because
No, because this is
Why?
a sample, not a population.
Yeah, it's not.
Here, let's
all
vote. Who
population.
thinks it's mu? Raise your hand. 1. Who thinks it's something else?
Yeah, it's just.
What's the something else?
standard.
I want to say,
Did you say S?
no, I don't think it's S. I think it's P.
You think it's P? What does P stand for? Proportion. Is this a proportion? 33 miles per hour?
No, it's the mean.
To mean, which mean?
Oh, no, this is the X.
The X bar.
It's X bar. Okay. Why is it X bar and not mu? Mu is a good guess, but it was wrong.
Mu is the population.
Mu is the mean of the population, and X bar is the mean of the sample. Okay. So you remember clear back on probably the second day of class where I said you had to identify the population in the sample? That just became really important, okay? All right, 33 miles per hour in a 25 miles per hour zone. What's 25?
That's the no hypothesis. Oh,
That's the, wait, yesterday. It's the,
it's the mu.
it's not alpha.
That's mu. The mu.
Is it the mu? Who thinks it's the mu? 1, 2, 3, 4,
That's for every.
5. Who thinks it's something else? Who didn't raise your hand? Liar, you didn't raise your
No, I
hand.
had it like this, sorry. I was too
Oh,
busy
yeah,
typing.
I'm gonna whisper all my answers and then I'm gonna put my hand up so you can't see it.
Sorry.
And then I'm gonna complain that you didn't see my hand up.
No, we're good.
Okay, it's mu. Why is it mu?
Because it goes for the entire population.
Yeah, the population is supposed to go 25. They're not going 25 maybe, but they're supposed to go there or less, right? Okay. Local police tell you the standard deviation is 8 miles per hour. What is 8?
Is standard deviation.
Which standard deviation? Is it sigma or S? Let's vote. Who says it's sigma? 1, 2.
Let's say I'm wrong.
Who says it's S?
Just because I don't mind being wrong.
1, 2, 3. Minority wins. It's sigma. Why is it sigma?
We know this is the population
How do we know it's the population?
because the local police are.
Because the local police would know the population better than anybody, right? Okay,
So sigma is population.
so we're assuming that the local police have the population, okay? Is there evidence that people are speeding? Oh, that should be a question, not a statement. Okay, are there any other numbers I should have?
Your alpha.
What's my alpha?
0.05.
Alpha's 0.05 because
Because it's not stated.
if it's not stated, you assume it's 0.05, okay? All right, so now step number 2 is,
Decide if it's categorical or quantitative.
is it categorical or quantitative?
This is quantitative. Because the speeds of people can be a whole range of numbers. It's not just one or the other.
Okay, who agrees with Bettina that it's quantitative? 1. Who disagrees with Bettina? Why do you disagree?
If they're the speeding or they're not.
Because they're either speeding or they're not. Oh, that's interesting.
I guess the question is asking if they're speeding or not what is their speed.
Yeah, well,
Would it be
Bettina
different what it was asking?
was right, because their speed can take on lots of different values.
Okay.
Okay? All right. So it's quantitative. Step number 3 is,
That's what it is.
step number 3 is where it gets confusing? Oh, 2?
I'm like,
Yeah. So remember when we talked about it on chapter 2? I think it was chapter 2 or 1, whatever those was. The skill, it just became very important, okay? As if it wasn't important already, okay? Step number 3 is
Either decide if it's a O or a H.
find the null or the alternative hypothesis, okay? The null I'm going to write as H and an O, so H sub 0, okay? What do we know about the null hypothesis?
Has always an
It's
equal
already
sign.
stated, like the null H equals 25 miles per hour. The null hypothesis is,
You said H equals,
well, H0 equals 25 miles per hour, or something. Like you're saying people go 25 miles an hour.
okay, so that's only half correct because she didn't include the right letter.
0.
0 equals 25?
No, H0.
H0, no, that's, yeah, you're still missing something.
H1 and HA.
Well, HA is the alternative hypothesis, but that's not what I'm looking for. Does n equal 25, x bar, mu, sigma, alpha, what equals 25?
Oh.
The mu.
Mu equals 25
Mu,
miles per hour.
okay? And I'm gonna write mu as mu. Because I don't know, well, actually, you know what? Somebody told me that you can actually write a mu in here. I'm trying to remember how to do it.
Null is HA, right?
How do people do that? Because some, their students will write a mu in here. I don't remember how to do it. I think if you use the math and trig functions, I don't care. Honestly, it doesn't matter. I'm fine with that. But there is a way to make the actual Greek letter in there. Students find it, and that's fine. Okay, now, what's the alternative hypothesis?
Mu is not equal to 25.
Mu is not equal to.
Mu does not equal to 25. Now, did the question give us any indication what we think is happening?
We think that they're speeding.
We think that they're speeding, so we think what?
It's greater than 25.
We think it's greater than.
How do you get those?
You think people are speeding in a school zone, you think they're going faster. So rather than just do the not equal to, I'm going to do the greater than. Okay? Now, I didn't really cover this very well yesterday, but if it's a not equal to, you're going to double the p-value. If it's just one side or the other, you're just going to find it. Okay? So this is what we would call a one-tail, or actually we would call this a right tail test.
Can you say that
Okay.
one more time? If it's a.
So here's what I'm going to cover the whole thing right here. If I had said mu was less than 25, that would be a left tail test. If I had said mu, and you can either write it as not equal to or not equal to, I don't care either way, whichever you prefer. That would be what we would call a two-tail test. Okay? With a two-tail test, you have to double the p-value. And I will explain that when we get there. Okay? In our case, of those three options that you could put for the alternative hypothesis, option 1 is correct. Okay? We're doing a right tail test. We think people are going faster than 25 miles per hour. Okay? So that's the correct answer for this problem. Okay? Step number 4. What is step number 4?
Pick the correct test and calculate it.
Yeah, so find the test statistic. And in order to do that, we've got 5 options, right?
Yeah, but we know it's down.
Okay, today's homework is only going to be one option. What is the equation we're going to use?
Then Z equals X.
Z equals X bar
So that's the quantitative.
minus mu over sigma over square root of n. Okay? And then I'm going to underline this so that it looks like a fraction. Okay? So now, because I have labeled everything just very nicely in step number 1, I can just go in there and start using numbers. What's X bar?
33.
33 minus 25, which is mu. Okay. My numerator is going to be 8. Oh, wow, that was interesting. Didn't expect that.
Yeah.
What's sigma? 8 divided by the square root of 8. Apparently, I like the number 8.
Yeah, that's great.
Never seen that happen before. Okay. So I've got my numerator divided by my denominator. I get 8 divided by 2.8, which works out to be 2.828. Oh, that's funny. That's what happens when you make up your own problem. They do weird things. Okay, so now step number 5 is what?
Find your p-value.
Find the p-value. Okay, and what's a useful thing when you're finding your p-value?
Your chart. Or
What would Rick do? He would
Dry
draw a picture. Would you like me to draw a picture on the board or on the computer?
on the computer so I can understand how to do it.
You don't need to draw it on the computer.
So we didn't.
It will look better on the board.
Oh, okay.
I'm not going to waste time on the computer because it can look bad.
Okay.
Okay, so here's what we've got going on the board. Okay? Where's my marker here? What am I drawing a picture of? Of the problem. That's not very specific.
Do a standard, do a.
We're gonna do a normal
The
distribution.
normal distribution, because why? By the way, we just broke a big rule.
I didn't draw it out.
Okay, what am I drawing a picture of? Let me ask you that question first. The normal distribution, what does the normal distribution assume?
Oh. That everything's between 0 and 1? Or, oh.
Well, eventually.
It assumes you
We know the mean's going to eventually be 0, but what is the mean currently? 25. Okay? Now, in order to use the normal distribution, how big does my sample size have to be?
Oh my gosh. Okay.
Oh, because we're not there, and
We only have 8.
so n has to be greater than.
N has to be greater than or equal to 30. How big was my N?
8.
My N was equal to 8, and you guys didn't even stop me there and say, oh, that's too small.
Heck no, boys, we're
That's
going
too small.
All right, I'll just take my C minus and I'll be done for the semester.
Okay, this is way too small, actually, right? Can you really do a histogram of 8 cars?
Not really.
What kind of people are these people? Okay? Now, there are ways to get out with smaller things, and I wasn't thinking when I did this, but yeah, this is too small, right?
Can we just change it? And then
Yeah, that's changing.
We can, but let's just keep it the way we are, okay? We're going to do it the wrong way anyway, okay? Because you guys didn't stop me earlier and say, this is way too small. Who's only doing 8 cars? You think the police would believe you if you only said, I measured 8 cars, they were speeding? Okay, all right, so that's an issue you should have caught already. How fast were our people going?
33.
They were going 33, which is faster than 25, right?
Yep.
Okay, they were going 33. Do we want to shade the area to the left or to the right? I'm going to turn out this light. I think it'll work better.
Yeah, I'm going to speak up and I'm going to say right, even though I'm probably wrong.
It's right, but you're wrong. I don't know if that's even better. It's way out of focus. Focus! There we go. Now it's better. Okay, you were right, Jordan. Okay, we want that area, right?
I hope so.
Now, even though this is too small, we're going to finish it just for practice. Okay. What value does 33 correspond to?
you have to look in the, like, it's,
It's the z-score we just calculated, which was
I didn't do that yet.
2.82.
2.82, right? Okay. All right, now, just for fun, now is this a right-tailed test, a left-tailed test, or a two-tailed test? And how do you know? It's a right-tailed test. Why? That's correct. The shaded area is on the right side of the graph. Why else? My null hypothesis was mu equals 25, and my alternative hypothesis was mu is greater than 25, okay? this greater than, it corresponds to that right tail. Okay, so that's how you know whether it's a right-tailed test, because of the greater than sign. Okay, I don't want you to think that's an equals though. You should never put an equals on your alternative hypothesis. Okay? All right, so in this case, we want the right tail. Now, there are two ways to find this, and I want you to be familiar with both ways. Okay? What are the two ways to find p-value? Chart or the computer, okay? Which method do you use when you're using the computer? Which method do you use when when I give you a test? Chart to the test, okay? You need to know both methods, okay? Now, we're going to do the chart first because I want you to pay attention to something, okay? Hopefully my chart is here. It's not here, why not?
Which actually, yeah, it's really weird. I don't even know. It's actually super cool though.
Oh, this is so annoying. I'm going to have to find it this way.
P to the left is 0.9812, and then you have to put 1 minus that.
I love how we just like hold this
I got stuck.
and then it's like, it just equals like weird stuff like this. I think it's kind of sweet.
How does it know if the last number is the same as the? Oh, because we got the square root of it. Oh, no.
Throw it in the trash. Throw it away. That's weird.
Man, I hate incoming students. I'm only saying that because I used to be an orientation leader for 2.5 years here. These are the two people that are always asking me so many questions, and then obviously everybody's so out here. Like, I'm only here to get this checked off so I can register for classes.
The worst. What's fun time as a people, right? Like way out. And for the orientation, they.
It's close enough.
It's so weird.
Yeah.
Like you have like these 20-year-olds like running around.
Oh, I didn't mean to do that.
I don't know, man. BYU just like makes you like maybe all the time.
It's funny because I went to,
I thought
when I did my orientation down in Northern Arizona University.
Oh, that's all right, I'll use this.
Where's the best place to go party at without being busted by the cops all the time? And they're like, we shouldn't really tell you that.
All right, here we go. Okay, now, by the way, I don't know that you guys, we've gone over this super well, because apparently you guys, I give you the formulas and you didn't even know they're there, okay? Norm as dis right there, do you see that?
Yeah.
Average gives the mean, median gives the median, quartile gives the quartiles. I give you all this stuff. I've even given you this stuff that we haven't learned yet, okay? Here's your chi-squared equations. Here's your, anyway. All this stuff is here and you guys don't even look at it. But what I wanted to do was look at this chart here. Now, on our chart, we want the area to the right. What is this chart giving you?
The left.
The area to the left, okay? I got a value of 2.82. What value does that correspond to?
0.098.
Let's see, that's this column here. 2.82, 0.9976, right? Is that the correct answer?
No.
No, it is
1.
1 minus that, okay? 1 minus 0.9976, except for I forgot the period there. Let's put the period in there, okay? So the chart gives me this value. Now, on the last test, I was nice, and I let you pull it off the chart. This next test, do not use the chart. Use the computer.
Why do we put full?
But if I use just the computer because I thought it was just computer.
On the computer, use the computer. That's what I'm saying. Now, you can also say 1 minus norm s dist, okay? Use the one without the periods, and then I can just click on my z-score right there. So rather than getting 0.0024, I get 0.002339. Okay? What is step number 6? So this is the answer you should
So I
use
have
when
a
you're using the
question. Null
computer.
exists, and then you just click on the 2.82 block, and that's what you
You
do.
gotta put the 1 minus
Yeah.
in there.
Well,
And then you can subtract it from 1 later if you want. But you can all do it in one step if you want. Okay? Because the computer works the exact same way as your chart. Okay? It gives you the area to the left.
You gotta close.
Oh, you're using the wrong one.
Yeah,
Yeah, you have the one without the periods.
Oh,
So this one.
Yeah, the other one you can use, but it's hard to use.
that's not.
Okay? Are we good?
Yep.
Okay, step number 6.
You want to accept or non-accept?
Oh, he used the A word. Wash out your mouth.
Or not reject? The other one.
Reject or do not reject.
But we shouldn't
We
say-
never use the A word in this class. Only if we like soap.
So
You know,
what did he say?
Lifebuoy tastes really bad.
Yeah.
So what did he say? That we should.
How did you become blind? It was soap poisoning. What'd you say, Sandra?
What was the word that we shouldn't say again? Average?
I don't want to say it again. I'll spell it ACCEPT. Don't use that word. It's a swear
Usually
word.
reject or not reject, because you can't really prove.
But then
the
you don't-
You
meaning.
can't prove something's true. You can only prove something's false.
If it's possibly more true.
But the thing, when you cannot use reject, because there is no rule.
You can always use reject or do not reject.
Until
Okay.
step 7.
Okay, so reject or do not reject. What is the phrase that pays?
Oh.
If
If the
If the something is low, reject.
p-value is low,
Your alpha.
reject the null. But it sounds like something else if you say it. Okay? So, is my p-value low?
Actually, it is because it's underneath your.
We're comparing this value to this value, right?
Way under your
So Aaron, I want you to give me this answer. Is my p-value low? So therefore I reject. Okay? Okay, so I'm going to reject this one here, right? This is what I'm rejecting. I'm rejecting that people are going 25 miles an hour. I therefore think the alternative is a better explanation, right? Okay? So step number 7 is the conclusion. What do we conclude, Sandra?
we conclude.
She's trying not to use that 3 words that she's not allowed to use.
Yeah, I'm just looking like which words. There is not evidence.
There is not?
Evidence.
There is not?
There is evidence.
There is?
There is enough evidence.
There is evidence that, what's the question that we're trying to answer?
People
Are people speeding? Is there evidence people are speeding, or is there not evidence people are speeding? Yes, it's one of those two. So you tell me which one to write. We've rejected the null. The null says people are not speeding. We've rejected that. So therefore,
there's evidence that they're not.
there's evidence that people are speeding. Okay? I know this last step is hard. You know what's frustrating for me? It's frustrating when people get any of the steps wrong, but what's really frustrating is when people get steps 1 through 6 correct and then screw up step 7.
Well, that's me.
Okay? All right. Now, let me just mention one thing about the homework. The homework is due tomorrow, okay, on chapter 17. Chapter 17 doesn't necessarily tell you to do the steps, but here's what I would like you to do on every single problem, and this is being recorded. do all 7 steps first, and then answer their question.
Oh, that makes life easy.
Okay? And you'll find out that if you do all 7 steps first, you've already answered their question more than likely. Okay? So just whatever it says, do all 7 steps first, and then you should just be able to go, oh, that was part B, that was part C, that was part D. Does that make sense? And in fact, if you would like, I will even do a homework problem out of the book.
Yes. Can I ask you one question about step 6?
Okay?
Okay, I understand that if P is less than alpha, then you reject it. And I understand that alpha is the area outside of the P value. But are we saying alpha, if P is
Okay.
less than the alpha, both the alphas or just one of the alphas? Then
Okay, so here's what's going on. Let me show you a picture.
Am I extending my question?
Yes, you're doing a good job. Okay? So here's what we're saying. Let me pick a different color. Oh, I've already got red and blue, and I don't want that to dry out. Let's pick, what color do I have in my pocket here? Red, perfect, okay? Now, this area in green is what? Is that the p-value or is that the alpha?
Alpha over 2. Right? Does alpha
Oh,
over...
now, actually, that's a really good question. You're asking really good questions. Let me back up a second here, okay? I'm going to draw another curve, okay? Has a mean of 25, okay? Now, the way that I've done this, is this a one or a two-tailed test?
One-tailed test.
This is a one-tailed test, so all of my alpha is on one side, okay? My alpha equals 0.05. Now, I don't know what this value is exactly. That's what I want my alpha to be, okay? Now, I've converted that to a 0. I still don't know what this is, okay? But I want my 5% all in one tail. This is a one-tailed test, okay? Now, and I know that this area here that I've shaded in red is 5%. What value did I get for my p-value? 0.0024. I left the lid off and now it's dried out, okay? So what we're saying here is that 33 miles per hour, this area here in green, is 0.0024, okay? This means I'm in my rejection region. So you can think of the red area as the rejection region. This area here is do not reject. Okay? So one way to think about it is, if you're in the white area, you do not reject. If you're in the red area, you reject.
Oh.
They actually refer to this as the classical method. Classical. I don't like to teach the classic. Sometimes students like the classical method. The problem is I'm going to teach you a bunch of different methods, and p-value goes to everything. Otherwise, the classical method, you're going to have to memorize a bunch of numbers, and who wants to do that? Okay? And when we get to the t-test, you're going to be like, oh my gosh, thank you for not making me memorize this table. Okay? So does that make sense? Tina?
I think so.
Okay. So visually, this is your rejection region. I got 33 miles an hour is in your rejection region. It only happens 0.2% of the time. Okay? Now, the only other problem is my n was very small.
The rejection region is defined before you even do any of the equations because it's always 0.05 unless otherwise stated.
Correct. Should we do one that's different? I was going to pick a problem.
One from the book.
Yeah, let's do the book.
Now, as I'm looking at these aren't, here, let me see. Okay, I'm going to do, this is problem 15 on chapter 17. This is problem 17, 15. This one looks like a good one because this is the way I would like you to do it. If we have time, hopefully we'll have time. This is going to be problem 17, 15. Okay? So here we go. We got people tend to be more generous after receiving good news? Are they less generous after bad news? Okay. 20 patrons give a tip after receiving a warning that tomorrow's weather is bad. Oh, this is actually really interesting. Suppose the percentage of tips is normal with sigma equal to 2. Is there good evidence the tip is less than 20%? Okay, and then I'm going to give you actual data here. 18, 14, 19.1, 17, 19.2, 13.6, 18.8, 17.5, 18.4, 20, 19, 20.2, 18.5, 18.8, 16.1, 18, 16.8, 23.2.
I'm not even trying to keep up, screw this.
This is 16. What is this one supposed to be? 16.8, I think. It's in your book.
Oh.
If you brought your book, you can just follow along. All right, so step number 1, okay? That's all it says, but this is good. I will do another one because it's a little different than this problem. But step number 1 is find all the numbers. Now, I gave you raw data this time, right? I didn't give you a summary data like I have up to now. I've given you raw thing here. Let's go thing here. People tend to be more generous. I got 20 patrons. What's 20?
N.
20 is N, right? Now, we should also count up to make sure that I actually typed in all 20. And I did. Okay, so I typed them all in. Okay, N is 20. After receiving a tip tomorrow, suppose the percentage of tip is normal with sigma equal 2. That was rude that they actually gave you the sigma. That have made you figure it out. Okay? Is there good evidence the tip is less than 20%? What do you think 20 is? Is it mu or is it p?
Oh, it is.
20 patrons.
No, this is,
Wait.
it's new, because it's continuous data.
Is this continuous data?
Yeah.
Because percentages can be proportions, right? Okay? This is a little bit different than do you support Donald Trump or do you not? If it was do you support Donald Trump or do you not, that would be a proportion. But since we're doing a restaurant bill, that's not a yes-no question, right? Whereas do you support Donald Trump? Yes, no, that is a yes-no question, okay? So percentages can be tricky. Often they are P, but in this case, it's mu. Do you see why? Okay? You don't see why?
You just say abortion.
Okay, proportions are yes, no. Is your tip on a restaurant bill a yes, no question?
No.
No, it could be, you've got a range of numbers, okay? So this is a case where it's mu, not p, okay? So that can be tricky, okay? Now, is there any other numbers that I should know?
Mu, sigma, X bar.
Or
I should probably figure out my X bar, right? This one's not given to me, I'm going to have to figure it out myself, right? X bar is what?
Equals average.
Equals average, and then you wash out your mouth, right?
No,
No. Jordan likes to swear.
I do all the time.
Okay,
That's why I can't.
so I got an X bar of 18.19, okay? Now, that's less than 20%, right? What have you noticed about your sample size? It's only 20, but they did tell you something very important here, okay? 20 is generally too small, right? But they told you, suppose it's known to be normal. Because it's known to be normal, I can get away with 20. Okay? If you know that it's normal, then 20 is okay. Normally, if you don't know that it's normal, you should get at least 30. Okay? So this is small, but okay since problem states it's normally distributed. Okay? So this one's okay to use a 20. Okay? All right.
If it doesn't say.
If it doesn't say it's normal, then you should get it to be at least 30. And in our case, we assumed that our cars were normal, but that's not an assumption you should always make. Okay? Step number 2 is
Categorical or quantitative?
categorical or quantitative, and the answer is Philip? Got a 50-50 shot. Just guess, because we got a lot of time. We don't have much time.
Quantitative because they give.
It is quantitative. All of your questions in chapter 17 are quantitative. On the test, that will not be the case. But all of the ones in chapter 17, so this is lucky for this chapter only, well, not for this chapter only. For this chapter, it will always be quantitative.
So we only have
Okay.
to know one formula.
So you only need to know one formula for this chapter. Okay? Step number 3, null and the alternative hypothesis, right? What is the null? Chandler. Twenty is only partially right. What letter am I using? Mu equals 20. Now, fair warning, this is being recorded on tomorrow's quiz. If you only put 20, you're only going to get half credit. It's got to be mu equals 20. If you put x bar equals 20, that is wrong. Okay? It's got to be mu. Okay? Alternative hypothesis is what, Christian? Mu, thank you. Where did you get greater than from? What is it asking you? Is there good evidence the tip is less than? So is it greater than? No, it's less than. Okay, this is going to be a one-tailed test. Okay? What if they left that question? Let me take this out for a minute. Or actually, let me change it. Or I'll change it this way. Is there evidence the tip is different than 20%? What would you do in that case? You'd put the not equal to in this case. Okay, this would be a not equal to. If it just said different, you don't know if it's higher, you don't know if it's lower. Now it looks lower, but we're not sure. Okay, I'm going to put that back here. Yes, so this one should be less than. Okay, I just wanted to point that out. If it was different, what would I do with the p-value at the end? I would double it, because I would be using both tails, not one tail. Okay? All right, step number 4 Find the test statistic. Okay, that means find the value as well. Aaron, what equation am I using for this?
Step 4 is equal to x bar minus mu over sigma divided by the square root.
Perfect, okay. I'll underline that. Jordan, can you help me type these numbers in?
Your x bar is 18.19.
18.19
Minus your mu, which is 20.
minus 20.
And then your bottom row is your sigma, which is 2.
2
And then divided by the square root of 20.
of this 20, okay? I'll underline that, so it looks like a fraction. This divided by that is negative 4.04. Oh, that's a good one. And this is step number 5. You define the p-value, right? Okay. And what do you guys not want to do that I tell you should always do?
Use the computer when you're on the computer.
Right, your
And
picture.
draw.
Draw your picture. We're going to stop sharing. We're going to draw our picture on the board. What's going on the board?
Something that's still underneath 30.
It's less than 30, but we said it was normal, so it's okay. Okay? So what am I drawing a picture of?
Normal.
Normal distribution. What's the mean of my normal? What is it?
20.
It's supposed to be 20, right?
Yeah.
I always thought it was 15%. When did they start changing it to 20? I swear that's been a recent change. What are we supposed to give them? Or what value did we get with our data?
Left.
We got 18.19, right? Okay. We've just converted that with my z-score formula to a mean of 0 and what does this value correspond to? Negative 4.04, right? Am I shading the left or the right? I'm shading the left. This area is my p-value. Okay. Now, let me show you something about this. This is kind of interesting here. Let's go to my chart.
Yes.
What do you notice about my chart? Where does negative 4 fit on my chart? It's off the chart. Now, I'm shading the area to the left, so what should my p-value be if I'm using the chart? Okay, if it's off the chart and you're using the chart, you're going to say your p-value is less than 0.0001. Okay, negative 4 is off the chart. You see that? Okay, I'm surprised. This was a good problem we did. I'm glad we did it because usually this doesn't come up in class. Okay, now, let me stop sharing for a moment. How would you do this on the computer? Okay, so if I'm using the chart, you would say that the p-value is less than 0.0001. If I'm using the computer, the command is what, Chandler? It's a good thing you got Bettina helping you out, Chandler. How did you not remember that? That should be like stamped in your brain. Norm-S dist of what? Negative 4. Thank you, Chandler Bettina.
Sorry.
Now look at that number. What is that number? That's an E there. What does that mean?
Going the wrong way, but
That means here, it's exponential notation, okay? If I were to write this out on the board, oh, I thought I was sharing and here we go. I shared wrong, but anyway. What's going on? It won't share. It just locked up on me. Okay, well, it's not being recorded. I don't know. The computer just screwed up on me. 0.1234, and then what was the next digit? 259, I think it was.
Oh, well, which one?
259, right? Okay. That's a really small number.
Yeah,
That's so small, I might even use the A word. Okay? I might accept that people are tipping less than 20%.
cheesesteaks.
Okay? I don't know if my video is being recorded because this is completely locked up though. So I apologize because it's locked up hard. Okay? Don't know what's going on with the video. Okay, so let's just finish this. You're going to have to take good notes. Step number 6 is reject or not. And Bettina, the answer is?
Okay, so the null hypothesis is that,
People are tipping 20%.
and so they're tipping lower, so
Is my p-value low?
That they're tipping less, or they're tipping less. Reject the null hypothesis.
Reject the null. Okay, so we're rejecting. So we believe this is not true. We believe 20% is not true. We've rejected 20%. And therefore, Alexander, the conclusion is
That we
have evidence
that people are tipping less than 20%.
Less than, I can't type, 20%
When they receive that news.
when they receive bad news. Yes. Okay. Does that make sense? Okay, now I don't know if it's recording. I don't know what it's doing. It looks like it's locked up hard.
Is determining if a number is low enough that you could accept it even going to be part of what we're doing, or is this like an exception problem?
This was surprising. Usually you're not going to get a z-score of -4. I'm kind of glad because when students get it in the past, they're like, I don't know what to do with this. It's off the charts. So at least you know that. Now, the other thing that I really want to carry out here, number 19, I just want to review this really quickly.
19.19?
Problem 19 on page 407. It says so this one has done all the hard work for you. This is one where they're just giving you the summary, okay? I don't know if this is recording or not, so you just have to say. 19 says you use software to carry out a test of significance. But they've just done all 7 steps for you. The program tells you the p-value is p equals 0.011. You conclude that the probability computed assuming h sub 0 is, and then you've got A, B, C. Okay, let's go ahead and read those. You have to decide if A is true, B is true, or C is true, okay? So remember, the key part to remember here, your p-value is 0.011, okay? So A says, let's see, you conclude that the probability, assuming that the null is true, of the testing value taking a value as extreme or more extreme, and actually observed is 0.011. Okay, is that a true statement?
Sure.
Who thinks A is true? We'll keep going. B says it's true of the test statistic taking a value as extreme or less than extreme is actually observed as less than is 0.011. Or C, false, of the test statistic taking a value as extreme or more extreme is actually observed to be 0.011. Okay? So, this one is asking you to interpret the p-value. So I'm going to give you, so you can answer A, B, or C. Who thinks A is correct? Nobody? Who thinks B is correct?
Be honest, I forgot about
Who thinks C is correct? And y'all got it wrong, A was correct. Okay? That's the definition of what the p-value is. The idea here is, when you're doing a p-value, okay, when we compute the p-value, we're saying it's as extreme or more extreme. Okay, that's why we're shading in this case to the left, although if it was a right-tailed test, we'd shade it to the right. The value of getting a value of 18.19 is as extreme or more extreme than the actual observed value. So the probability in this case, let's apply it back to this problem we just did. The probability of getting an 18% tip or lower, more extreme is lower in this case, happens 2/100,000th of a time. That wouldn't happen very often. That's very convincing evidence that the null hypothesis is not true. Okay? So that one was just asking you to interpret. We're way out of time. And so quiz tomorrow is going to be on chapter 17. What I really recommend, do all of the problems, do all the 7 steps. Obviously with problem 15, you couldn't do all 7 steps because they didn't give you any information. They did it for you essentially. But do all 7 steps and then try to answer the question. Okay?
So the problems are the ones that we have for homework, right?
Correct.
I'm gonna say, enjoy eating the data. That's all I'm gonna say.
Do you guys want a copy of this spreadsheet?
I'll take
Yes,
one.
please.
Okay.
And that's due Thursday, right? It's tomorrow, it's a holiday.
Oh, that's correct. Thank you.
Yeah, I was gonna say, I don't know about you guys, but I'm planning on enjoying tomorrow.
You're going to withdraw tomorrow?
No, I'm gonna sleep or go eat or go get a, so there's a place called Rocket Fizz, and they do weird random sodas. And they have like pie soda, like lemon and ice. Like I said, enjoy collecting the data